Current electricity numerical, March 2014. A battery of internal resistance 3 ohm is connected to a 20 ohm resistor and potential difference across the resistor is 10 volt. If another resistor of 30 ohm is connected in series with the first resistor and a battery is again connected to the combination, calculate the EMF and terminal potential difference across the combination. Here the given thing. Here we have a cell, its EMF is not given. That's what we need to calculate. And its internal resistance is given, that is R, small r is equal to 3 ohm. Now this cell is connected to an external resistor, its resistance is 20 ohm. Let's write it as R1 is equal to 20 ohm. And potential difference across this R1, that is V1 is equal to 10 volt. We need to calculate the EMF of the cell. This is the first case, this is our case number 1. Here in second case, another resistor of 30 ohm is connected in series with the first resistor, that is R1 is equal to 20 ohm. Now, here we need to calculate the potential difference across this combination, that is V2 is equal to question mark. Let's find EMF of the cell first. To calculate the EMF of the cell, we need to know this formula, that is I is equal to EMF divided by external resistor plus internal resistance. Here I1 is equals to E, that is EMF of the cell, divided by R1, that is external resistor, plus small r. Let's write it like this. I1 and hege baritani. I1 is equal to, we can write V1 by R1 anta baribodu. And substitute that I1 value V1 by R1 here. Instead of I1, we are writing V1 by R1 is equal to E divided by R1 plus small R1 plus small r. Take it left side. Here R1 plus small r into V1 divided by R1 is equals to E. You can write it like this. E is equals to E is equals to same equation. E is equals to R1 plus small r into bracket V1 by R1. Now substitute the values in the substitute. What is R1 here? R1 is the resistance of the resistor, that is 20 ohm. And what is that small r? Small r is 3 ohm. That is internal resistance of the cell. Here it is 3 ohm. And what is V1? V1 is potential difference across the R1, that is 10 volt. Here that V1 is 10 volt. And again R1 is equals to 20. It is 20 plus 3, 23 into 10 divided by 20. Here this 0 get cancelled. 23 divided by 2 means the EMF of the cell is 11.5 volt. What is this? This is the EMF of the cell is, the EMF of the cell is, it is 11.5 volt. What next? Next we need to calculate here another resistor, its resistance is 30 ohm, which is, we are connecting in series with the 20 ohm resistor to the same combination. Here same cell, the cell is same cell, it has same internal resistance R, and now we need to calculate V2, that is potential difference across this combination. For that, here the EMF of the cell is 11.5 volt, R1 20, R2 30, these two are in series. You need to calculate V2, that is potential difference across this combination. Again, here I2 is equals to E divided by RS plus small r. What is RS? Here two resistors in series, the effective resistance will be R1 plus R2, that is RS. I2 is equal to V2 by RS, and therefore here V2 divided by RS, instead of I2 you can write V2 by RS is equals to E divided by RS plus small r. We want V2. Here RS, take it right hand side, ಏನಾಗುತ್ತೆ RS into E divided by RS plus small r. Here RS is R1 plus R2 because these two resistors are in series. Here R1 and R2 are in series, therefore RS is equals to, that is, you can write R1 plus R2, 20 plus 30, that is 50 ohm. Here RS is 50 ohm. EMF of the cell is just we calculated earlier, that is 11.5 volt. And small r is internal resistance of the cell is 3 ohm, that is given. And substitute RS, here is a 50 ohm. What is EMF of the cell? EMF of the cell is 11 volt. We have earlier calculated, right? RS is again, that is 50 plus small r is 3. Now 50 into 11.5, it is 575 divided by 50 plus 3, that is 53. You will get V2 is equals to 10.48 volt. What is this? This is the potential difference across this combination, that is a 10.48 volt. And EMF of the cell is 11.5 volt. That is the first case, and potential difference across the combination is, that is 10.48 volt.